Hold on. Yeah, just lower it in there and see. Yep, there you go.
Oh, there's a lot in there.
There's a lot. And as a matter of fact, can you see?
Pieces of smoke.
Pieces of smoke.
Just sitting there.
Well, greetings back at Faraday Studio. I'm Jake Wizard 4, and this is my wizard in training, Beckett.
Yep.
Well, listen, I tell you what, we're going to try to get you to sharpen some science thinking skills, right?
Yep.
So what do you see right in front of you right now?
Well, I see some matches,
Matches.
a candle,
Yeah.
and a jar.
And a jar.
Yep.
Okay. Now let's look at that jar.
All right.
You can grab your beard and go,
Is it a gas?
So it's a jar filled with gas?
Yep.
Is that what you're saying?
Yeah.
There's something amazing, something powerful is in that jar. And you know, it's like the old thing of letting the genie out of a lamp or something. There's something in that jar. Well, let's see if we can figure out any properties of that gas just by looking at it before we do anything with it. What properties could you tell me about that gas?
You can't see it. It's see-through.
See-through? Is there a name for that see-through? What's the name for see-through?
Transparent.
There you go. Now you can show up transparent. It's a transparent gas. Yeah, right. That's right. What I'm going to have you do is open the lid.
Okay.
And pour that gas onto that candle.
Okay.
In case we have an accident, everybody say goodbye, Beckett. Bye, Beckett.
Whoa.
That's sweet, wasn't it? Let me do that again. Oh, yeah, that's sweet.
That one worked really well. There was a ton in there.
You know what we call that?
Gas.
It's gas.
Gas.
It's a special name. You're in the presence of who?
The wizard.
So what do you think we call that?
Wizard gas.
Wizard gas. We have wizard gas. So the first thought that comes to your mind is?
Mr. Wizard's gassy.
Well, there's that. It's part two. You're calling me gassy? Two other properties that just made themselves known to you. First one is transparent.
Yep.
What other properties?
It's non-flammable.
You know, obviously, it's not going to burn. There's a property of it, right?
Yep. It poured, which means that it's heavier than air.
More dense than air.
Okay, more dense.
You remember that? Yeah, more dense. So see, just in that simple thing, we're able to describe three properties of this unknown stuff.
Where can I get some of that?
You want to get some of that?
Yeah, I do.
Nothing better than having a jar full of wizard gas. Let me tell you, all this gas is carbon dioxide.
Really?
Yeah, CO2. It's the same gas that you exhale. When you breathe, you inhale oxygen, and a little bit of what comes out is carbon dioxide. When you breathe in, you're breathing in mostly nitrogen. 80%, about 79% is nitrogen. About 20% or so is oxygen. And when you spit it out, only 1 or 2% comes out as CO2. So in order to make CO2, which we've made CO2 many times, pull over the fancy reagents that you need to make some CO2.
Distilled white vinegar.
And here's some baking soda. And that's sodium, say this, sodium bicarbonate.
Sodium bicarbonate.
And we won't worry about the chemistry of it, but bicarbonate, that means there's some carbon and oxygen attached to the sodium atoms in there. And that when the acid reacts, it gives off some CO2 gas. This is a fancy little plexiglass tank that I really like. I bought some of these, I think, from a teacher's supply store. So why don't you sprinkle some powder right down in the bottom of this.
All right.
Notice I set 2 empty beakers in there. Just put a slug of that in there. You don't want to disturb the gas that's in the tank. Because what did you say one of the properties of this gas is?
It's heavier than air.
Yeah, more dense again?
More dense.
Okay, it should stay in there. But if you start moving your hands over the top of the tank, it'll swirl it up, mix it up. So we kind of stay back here and kind of keep it. And you say, well, I don't see the carbon dioxide, do I?
Nope.
You don't see it. So how would you know if it's there? So one of the ways is, here, I'll have you do this. You take the match, you just hold it, and I'm just going to have you light the match. Hold on, yeah, just lower it in there and see. Yep, there you go.
Oh, there's a lot in there.
There's a lot. And as a matter of fact, can you see?
Oh,
what do you see?
That's cool. It's like these little pieces of smoke.
Pieces of smoke.
Just sitting there.
What do you call a piece of smoke?
A wisp.
A wisp. The man is brilliant. You're gonna be a wizard. You know the word wisp. That's a wisp of smoke. So we know the CO2 is about here, right? Mm-hmm. And you know, I've got these 2 beakers in there.
Oh.
So you think they're full of CO2 now?
Probably.
Yeah, probably are. Here he goes. Sweet.
Is there enough in there?
Yeah, oh, it disturbed it. Okay, you kind of slopped it around there, didn't you? I'm going to have you look at what I set up over here and see if you can figure out what we're going to do. what do you see in front of you? Start at this end.
Okay, well, there's a cake,
Cake,
candles
candles on the cake,
on the cake. Then there's a big pipe.
big pipe. So what do you think we're gonna do?
I think we're gonna use some wizard gas
Wizard gas,
to put out the candles.
put out the candles. Why did I design that pipe the way it is?
So you can pour some CO2
Yeah.
down the pipe,
Yeah.
and that'll hit most, if not all, the candles,
Why do you think I put that cap up there at the end?
so that it doesn't go that way.
Yeah. See that little process you're doing so it doesn't go that way?
Yep,
That's thinking like a scientist. And you just figured that out by looking at it.
yep.
Yeah, that's what we do here. We just looked at it, we figured it out. Why do you think I put those candles in that way?
When it comes down the pipe, it'll go in a straight line across the candles.
Yeah. Maybe we'll be able to see it progress across the flames.
See how far it'll go.
Because something's making this gas go
Yeah.
down through the tube. What is it?
I think it's the slant of the tube.
The slant of the
and
tube.
since it's heavier than air, the air's in the tube, denser than air,
Yeah, that's the answer.
denser. So it's gonna move down through the
So
tube.
what's making it move?
Gravity.
Gravity, there you go.
Got it.
Yeah, so we're using gravity as our friend. This is directing the pull of gravity down through that tube.
Yep.
You get yours lit before the old man? There we have it, ladies and gentlemen. We have the
all
candles.
lit.
Try to pour it slowly down that tube. I don't know, we've got several jars in case this doesn't work.
Yeah,
So.
just in case.
Ooh, look at that, did you see that?
How many did we get?
Well, we got the middle bunch. But did you see that coming out of there? And it was highballing it too. This is what we do for a living here. We blow out candles the hard way.
Yep.
Must have accelerated. Here we go. Oh, it's going. It's going. You got one more. There you go. Dump, see if there's any left. Hey, that was great.
Oh, there was a ton in there.
There was a ton left in that jar. This is just one of 200 activities.
Man, 200?
200, yeah, from the Wizard collection. You know, we've got a collection that's about 225 years old, and so we're taking 200 of those activities that you can do at home or at home school or at Boy Scouts or in the classroom or whatever to sharpen your thinking skills.
Yeah.
And it doesn't cost a lot of money. You don't have to have a birthday cake.
Yeah, you don't have to have a cake. You just gotta have some candles.
Yeah, you just have some candles. You can think of 100 different things to do with this Wizard gas. That's what we do here at Faraday Studios. So thanks. And say goodbye, Beckett.
Bye-bye.
Okay, you did pretty good today.
Yeah.
Thank you.